Hi, let's start with our first chapter, States of Matter. Definition: substance that occupies space and has mass. Composition: can be element, compound or mixture. Physical state: solid, liquid or gas. Let's talk about kinetic particle theory of matter. Fundamental principles includes: first is core concept, which is that all matter consists of tiny particles, that is atoms, molecules and ions. Second thing, particle movement. So particles are constantly in motion. Temperature affects particle energy. Movement varies across different states of matter. Now let's talk about particle arrangement in different states. Solids. The characteristics of solids are that these particles are packed closely together. They have fixed regular lattice arrangement. The particles vibrate in fixed position and they have definite shape and volume. The behavior is limited movement, strong intermolecular forces. Next we have liquids. The characteristics of liquids are their particles are closely packed, irregular arrangement they have. Their particles can move past each other. They take the container's shape and they have definite volume. The behavior of liquid is that they have fluid properties and moderate particle mobility. Now let's talk about gases. The characteristics are particles spread far apart, completely random arrangement, particles move randomly and rapidly, and they have no definite shape or volume. Now let's talk about behavior. Highly compressible and expansive. Now, changes of states, energy and particle movement. In changes of states, we talk about energy and particle movement. The first is heating process. Heating increases the particle energy and it weakens the intermolecular forces and it enables state transitions. Now, let's talk about state change mechanism in melting. The solid states converted to liquid. In boiling, the liquid gets converted into gas. In condensation, the gas transforms to liquid, and then in freezing, the liquid turns into solid. Now, next we have pressure and temperature effects. Now, in gas behavior, the pressure impacts are when you increase the pressure, the particle gets compressed. So, there will be particle compression. Decreased pressure will result in particle expansion. Now, temperature impact. High temperature will increase the volume and lower temperature will result in decreased in volume. Some key terminologies which we must know are atom. These are the smallest particle of an element participating in chemical reactions. Second is molecule, group of atoms connected by covalent bonds. Next we have intermolecular space, space between the particles in matter. Next we have intermolecular forces, weak attractive forces between molecules. Now let's talk about a practical example of Saturn's composition. It demonstrates unique physical states under extreme condition. Rings composed of varied size ice particles. Atmosphere contains hydrogen, helium, ammonia and methane. Now, visualization of particle movement. Some critical insights are that the particle theory explains about state transition, volume changes, diffusion processes and compressibility variations. Now let's talk about states of matter and diffusion, solubility of gases in liquid and their key characteristics. So, the temperature impact here is the gases become less soluble in water as temperature rises. Oxygen solubility, small amount sufficient to support aquatic life. And then pressure relationship is that solubility increases with pressure. Now, practical examples like sparkling drinks that contains carbon dioxide dissolved under pressure. Fizz when pressure is released, go flat when left open, especially in warm environments. Now let's talk about diffusion in fluids. Fundamental principles. Number one, particle move from high concentration to low concentration. Very important point. Eventually, particles become evenly distributed. Diffusion rates. Now, very important again, it is slowest in liquid, fastest in gases, and does not occur in solids at all. Now, diffusion mechanism, gas diffusion. Gases fills entire available space. It enables sensory experiences such as smelling. Particle movement characteristics includes high-speed molecules around 1,800 km per hour and frequent collision. Collision rates impact overall diffusion as well. Factors that affect the diffusion rate: particle mass, it affects the diffusion rate. So lighter molecule diffuse faster, inversely related to particle mass. Temperature, higher temperature increases particle speed. Now, the experimental insights. Diffusion investigation experiment. Here you need the materials such as petri dish, deionized water, silver nitrate crystals, and potassium iodide crystals. Some safety considerations include wear eye protection, use tweezers, avoid ingesting chemicals, wash hand after handling, and proper chemical waste disposal. Now let's talk about kinetic particle theory. The key points include particle behavior. There is a constant motion in their particles. Different movement characteristics are there in solid, liquid, and gaseous state. Motion is influenced by temperature, particle mass, and molecular size. Some visualization strategies is like modeling particle arrangement. You can use physical representation such as balls, marbles, cards, demonstrate particle movement in different states. Explore the questions such as transition of states such as from solid to liquid as discussed earlier, melting processes, and diffusion limitations. Some key concepts of matter and particle movement. Here we have an overview of states of matter. So fundamental states are solid, liquid, and gas. Then particles have different characteristics in each state. Movement and space of particle determine state properties. Then particle arrangement and movement. Solid particles are tightly packed, vibrate in fixed position, least mobile state. In liquid we have particles close together, can move past each other, more mobile than solids. Maintain volume but takes container shape. Then we have gas. In gas we have particles widely spreaded, move rapidly and randomly, no fixed position, and expand to fill the entire container. Key processes of state changes includes diffusion. The definition is the spread of particles from high to low concentrations. Very important. Occurs in gases most effectively. Driven by random particle movement. Now speed depends on three factors, very important, that is particle size, temperature, and concentration gradient. Phase changes include melting, which is from solid to liquid transition, occurs at a specific melting point, requires energy input. Boiling, evaporation, liquid to gas transition, occurs at specific boiling point and involves significant energy absorption. Third is condensation, gas to liquid transition, occurs when gas cools down, releases energy. Next is freezing, liquid to solid transition, occurs at specific freezing point and it involves energy release. Some experimental observations, perfume diffusion experiment such as demonstrates particle movement, smell spreads through random motion. Factors that affecting speed are particle size, room temperature, and travel distance. Then we have gas diffusion experiment. Here we have different gases with different diffusion